All right, welcome to The Explainer. Today we're going to tackle one of the most fundamental, most familiar, and yet most mysterious forces in the entire universe: gravity. I mean, think about it. It's the reason an apple falls from a tree, the reason we have weight. It's so constant, so present in our lives, we barely even give it a second thought.
But then you zoom out, way out, and you realize it's also the master architect of the cosmos. It's the silent force that sculpts stars, herds planets into orbits, and weaves together the vast, beautiful structures of entire galaxies.
So we feel it, we see its effects everywhere, but what is it really? For literally thousands of years, humanity has been wrestling with that question, and every time we find a new answer, it completely revolutionizes our picture of reality. Our story, our real quest to understand gravity, begins by taking a sledgehammer to an idea that stood for nearly 2,000 years, an idea that came to us from the ancient Greeks. So early thinkers like Aristotle had ideas that, well, they felt right, A heavy object falls faster than a light one. It just makes intuitive sense. But then came the scientific revolution, which said, intuition is nice, but let's test it. It was a whole new game, replacing philosophy with cold, hard experimental proof. And this is where Galileo comes in. His experiments were just genius. By rolling balls down ramps, he could slow down gravity's effect and actually measure it. And what he found shattered the old worldview. He proved that everything accelerates at the exact same rate. That old idea? Gone. This paved the way for a real mathematical understanding of gravity. Okay, so the stage is set, and then in the 17th century, one person has this incredible moment of insight that connects the world at our feet to the stars in the sky in a way no one ever had before. We all know the story of Isaac Newton and the apple, right? But the real stroke of genius wasn't just observing a falling apple. It was asking, is the force that pulls this apple to the ground the same force that holds the moon in orbit around the Earth? He realized the answer was yes, it was universal. And get this, he described it all with a single, incredibly elegant equation. Basically, more mass means more gravity, and more distance means less gravity. All of a sudden, the universe wasn't this mysterious, unknowable place. It was a giant, magnificent clockwork, taking away with perfect mathematical precision. And let me tell you, Newton's theory was a smash hit. It worked for everything: cannonballs, planets, you name it. It was so good that when astronomers saw tiny wobbles in the orbit of Uranus, they used Newton's law to predict that an undiscovered planet had to be there. They pointed their telescopes and boom, there was Neptune. Just incredible. For more than 200 years, Newton's universe was perfect. But as our tools got better and our measurements got more precise, a tiny little crack started to appear in that perfect clockwork machine. So, was Newton's law the final answer? The ultimate truth about gravity? The answer, it turns out, was a huge, resounding no. The universe was about to get a whole lot weirder. And it all came down to one stubborn little planet, Mercury. Its orbit was wobbling, shifting over time by a minuscule amount. We're talking a tiny fraction of a degree over a whole century. But it was a fraction that Newton's math just could not explain. And this tiny error was a clue that our entire understanding of gravity was about to be turned on its head. And then along comes Albert Einstein. He looks at this problem and proposes something so radical, it's hard to even wrap your head around it. He said, what if gravity isn't an invisible force, pulling things together at all? Okay, stay with me here. Imagine a big, stretchy trampoline. Now, you place a heavy bowling ball in the middle. What does it do? It creates a big dent, a curve in the fabric, right? So if you roll a little marble nearby, it's not being pulled by the bowling ball, it's just following the curve in the trampoline that the bowling ball created. That, Einstein said, is gravity. Mass tells space-time how to curve, and that curve tells other objects how to move. Now, this was a wild, almost unbelievable idea, but it made some crazy predictions, like that starlight should literally bend as it passes the sun, that space-time itself could ripple like a pond, that there could be places where gravity is so strong not even light can escape. And one by one, observation after observation proved him right. So, Einstein gave us this beautiful, mind-bending new picture of gravity. It's the best one we've got. But in solving one set of mysteries, he accidentally uncovered even bigger, even stranger ones. And this is the part that just absolutely blows my mind. Because it turns out that everything we can see, everything we've ever studied, the stars, the planets, you, me, this screen, all of it makes up a measly 5% of the universe. The other 95%, we call it dark matter and dark energy, and we have almost no idea what it is. Our current models just don't work without this stuff. We see galaxies spinning so fast they should be flying apart unless there's a ton of invisible dark matter holding them together with its gravity. And we see the entire universe not just expanding, but expanding faster and faster, pushed apart by some mysterious dark energy. Clearly, our quest to figure out gravity is far from over. So you can see our story of gravity is still being written. Right now, physicists are trying to pull off the next great revolution, uniting Einstein's giant, cosmic gravity with the strange, tiny world of quantum mechanics. Which leaves us all with one final, incredible question. Is our entire understanding of reality about to get warped all over again?